Welcome to the deep dive. You know, when you step outside on a clear night and you look up at the sky, you probably think about empty space.
Oh, absolutely. Just endless void.
Right. You see a few pinpricks of light and you just think about the sheer unfathomable distance between us and, well, everything else.
It's a very natural human reaction to that scale.
It is. But today's source material is on a mission to prove that looking at the physical size of the cosmos is honestly a completely backward way to understand reality.
It really challenges that whole perspective.
Exactly. We're looking at a brand new, highly anticipated paper from Dr. Melvin Sewell, the academic dean and diagnostic architect at the Cosmic University of Echo Rift Studies.
A brilliant mind, really.
Yeah, his paper is titled Black Holes, Informational Density, and Multiversal Reality Levels, a category theoretic framework.
Quite a mouthful, but so important.
It is, and the core argument here is just radical. He's saying the true measure of a universe isn't its physical volume. It is how much compressed data it's holding.
Right, the hidden complexity.
Exactly. So today, our mission is to unpack this framework that maps the multiverse, not by stars and void, but by pure information.
Which is just a phenomenal piece of theoretical architecture. What Dr. Sewell is doing at the Cosmic University of Echo Rift Studies is, well, he's providing a formal taxonomy for multiversal modeling.
Okay, let's unpack that a bit.
So he is taking three highly demanding fields entropy, quantum information, and category theory, and he's weaving them together to actually categorize reality itself.
Wow. All three at once.
Yes. He's essentially saying that our obsession with the geographic size of the universe is just a localized bias.
We just like big things because we're small.
Precisely. To truly classify different levels of existence, we need a completely different set of rulers.
And to use those rulers, we have to start with the foundational metric of this entire paper, right? Sewell calls it the Reality Level Scalar, or the RLS.
The RLS, yes. The core equation.
And the formula looks, surprisingly simple on paper. It's RLS equals S divided by V.
Where S is entropy and V is volume.
Right. So we're taking a universe's entropy and dividing it by its physical volume to find its informational density. But, and I want to stop right there and push back on something for a second.
Sure. Go ahead.
Whenever I read about entropy in standard physics, it's almost always in the context of the second law of thermodynamics.
Right, the classic definition.
Yeah, like it's decay, it's the engine losing heat, the car rusting, the whole system falling into chaos. So why is this framework rewarding a universe for falling apart?
That is such a common sticking point.
Like, why use a measure of decay as the numerator for measuring reality?
Yeah, that is the exact hurdle most physicists really have to clear when they move into information theory. You have to completely divorce the concept of entropy from that colloquial idea of, say, a messy room or a rusting car.
Okay, so it's not about messiness.
Not at all. In quantum mechanics and information theory, which is the absolute bedrock of Dr. Sewell's framework entropy, is actually a measure of hidden state complexity.
Hidden state complexity.
Right. Think of it less as decay and much more as the capacity for microscopic variation.
Oh, I see.
If you have a highly complex system, there are billions of possible internal microscopic configurations that can exist, all without changing the outward macroscopic appearance of the system.
So it's basically about how much data is operating under the hood.
That's a great way to look at it.
It's like the difference between a massive external hard drive that, physically takes up half your desk but only contains a single text file.
Yes, mostly empty space.
Versus a microscopic little flash drive that is just loaded with heavily compressed interlocking zip files.
Exactly. The physical volume of the flash drive is tiny, but the hidden internal complexity, the entropy, is massive.
That makes so much more sense.
It's a highly accurate way to frame it. The reality level scalar isn't measuring how big the room is. It's measuring how densely the information is packed into whatever space is available.
So a high RLS means...
It means you have a staggering amount of underlying quantum states packed into a very tight volume.
Okay, so S divided by V gives us this raw density score. But, a single number doesn't build an entire multiversal taxonomy.
No, it doesn't.
Just knowing the density of something doesn't tell you how it functions or where it sits in some grand hierarchy.
Which is exactly why the scalar is only the first step. To actually sort and classify these universes, the framework introduces the reality level analyzer.
The RLA.
Right. The RLA, it is the diagnostic tool that takes that raw density score and applies advanced quantum information measures to see what kind of informational architecture is actually present.
And the paper specifically highlights three measures the RLA uses. There's von Neumann entropy, mutual information, and relative entropy.
Yes, those three are critical.
But let's not just list them. How do these actual mechanics help sort a universe? Let's start with von Neumann entropy. If classical entropy is just hidden data, what is the von Neumann version doing differently?
Well, von Neumann entropy deals specifically with quantum entanglement. See, in classical systems, information is distinct. A 1 is a 1, a 0 is a 0. But in a quantum system, particles exist in superpositions and entangled states.
They're all mixed up.
Exactly. Von Neumann entropy measures the purity of that quantum state. If a system is highly entangled with its environment, its von Neumann entropy is high.
So it's measuring the connections.
Right. The RLA uses this to determine how fundamentally interconnected the fabric of a given universe actually is.
Which leads right into the second measure, mutual information. Because if I have two entangled particles and I measure the spin of particle A, I instantly know the spin of particle B, right?
Precisely. Knowing about one subsystem reveals data about another.
Got it.
And mutual information quantifies that exact relationship. It measures the strength of the correlations between different regions of a universe.
Okay, and what about relative entropy?
Right. Finally, you have relative entropy, which acts as a measure of statistical distance.
Yeah.
It calculates how difficult it is to distinguish one quantum state from another.
Uh,
So by running the reality level scalar through these three specific filters, von Neumann entanglement, mutual information sharing, and relative entropy distance, the RLA can categorize a universe into one of four distinct tiers.
and this is where the paper shifts from, mathematical definitions into an actual map of the multiverse. Armed with the RLA, Sewell essentially builds a ladder.
A hierarchical ladder, yes.
And I want to walk you through these four tiers because the first rung is where I personally experienced some genuine existential shock.
It is quite humbling.
It really is.
Yeah.
The framework defines the bottom tier as level alpha, and it is subtitled diffuse.
Yes, level alpha represents universes with incredibly low informational density. The RLS, that entropy divided by volume, is nearly negligible here.
Negligible. And the prime example the framework gives for a level alpha diffuse lowest tier reality is our entire observable universe.
That's right. Us.
Wait, like everything the James Webb Space Telescope has ever captured? Billions of galaxies, trillions of stars?
All of it.
We are the bottom rung. We are basically living in the empty suburbs of the multiverse.
I mean, look at the denominator of the RLS equation. The volume of our observable universe spans tens of billions of light years.
It's unimaginably huge.
But what actually frees that volume, the vast, overwhelming majority of it, is just a vacuum of space.
Pure emptiness.
Exactly. The actual matter, the complex quantum states, the concentrated information, it is spread infinitesimally thin.
Right.
So the numerator is relatively tiny compared to that astronomical denominator. From a purely mathematical standpoint, a vast expanse of mostly nothing is the very definition of a low-density level alpha reality.
But hold on, if we are basically just a rounding error of empty void, how are we having this conversation right now?
That's the key.
Because pure vacuum doesn't host deep dives or build telescopes. There clearly is complexity here.
You identified the exact causal bridge to the next tier. The void itself cannot host complexity, which is why matter and energy must locally concentrate to function. And that brings us to level beta, which the framework subtitles structured.
Okay, so we move from diffuse to structured.
Yes, level beta realities have a moderate informational density, and the framework uses galaxies as the primary physical example of level beta.
Oh, because they clump together.
Exactly. Because gravity pulls matter together, it reduces the effective volume and dramatically spikes the entropy, the complexity, within a localized region.
It's like looking at a massive empty ocean, which is alpha.
Right.
But scattered across that ocean are these incredibly dense archipelagos, the islands of beta.
That's a beautiful analogy.
Thanks. So within our vast empty alpha universe, the galaxies themselves operate as these higher tier beta realities. They are the structured hubs where that S over V equation actually starts to yield interesting complex results.
Absolutely. But that structure is entirely reliant on physical boundaries. Level beta is still playing by the rules of spatial geography.
Physical space still matters.
Yes. But to reach the third tier, level gamma, the framework demands a complete departure from macroscopic physics. Level gamma is subtitled entangled.
Entangled. Yeah, the paper describes level gamma as hypothetical coherent universes built entirely on advanced quantum correlations.
Correct.
So if beta is a galaxy held together by gravity, what does a gamma universe actually look like?
Well, to understand gamma, you really have to remember how the RLA measures mutual information.
Okay, the correlations.
Right. In our physical beta realities, information takes time to travel. It is bound by the speed of light and the physical volume of space.
Right, there's a speed limit.
But in quantum entanglement, spatial distance is totally irrelevant. If two systems are entangled, an interaction with one instantaneously correlates with the other.
Okay, let's ground that for a second because it's a massive conceptual leap.
It is.
Think about level alpha and beta like sending a physical letter across the country. You have to write it, put it in an envelope, and physically transport it across a huge volume of space.
Which takes time.
It takes time. And the distance dilutes the speed of the information. But level gamma is like a shared cloud document.
Oh, yes.
Like two people are looking at the exact same file on different sides of the planet. If I delete a word on my screen, it vanishes on yours at the exact same moment.
Instantaneously.
Right. The physical volume of the Earth between us has absolutely zero effect on the shared information.
That is an excellent analogy. In a level gamma coherent universe, everything operates like that shared cloud document.
Wow.
The physical volume, the V, in our equation, ceases to act as a diluting factor because the quantum relationship networks are perfectly correlated. The connections themselves constitute the reality.
So the math just goes off the charts.
Exactly. Consequently, the reality level scalar skyrockets. You have massive quantum complexity that simply ignores spatial constraints.
Which naturally sets up the ultimate boundary condition, because we've gone from the empty ocean of alpha to the island structures of beta to the instantaneous cloud network of gamma.
We're climbing the ladder.
But what happens when that cloud server is pushed to its absolute physical maximum? Like what happens when you pack the highest possible amount of entropy into the smallest conceivable volume until the framework simply cannot compress the data any further?
Then you reach the absolute apex of Dr. Sewell's taxonomy, level omega, the ultra-dense reality.
And here's where this paper completely rewires modern astrophysics.
It really does.
Because the prime example the framework provides for level omega isn't some hypothetical mathematical construct. It's black holes.
Yes. It forces a total reevaluation of how we view these phenomena.
I'll say.
In classical physics, and certainly in popular culture, black holes are mostly characterized by their destructive properties.
Yeah, giant vacuums.
Exactly, they're cosmic vacuums that consume light and matter, tearing structures apart in a gravitational singularity.
We treat them as dead ends, a tear in the fabric of space where information just goes to die.
Right.
But Sewell is arguing the exact opposite here. He is treating black holes as the absolute peak manifestations of multiversal reality.
Yes. And to understand why, we have to look at how black holes interact with informational density, specifically regarding the holographic principle.
Right, the holographic limit.
In physics, there is a theoretical limit to how much information you can pack into a region of space before it inevitably collapses into a black hole.
Okay.
But what's vital here is how that information scales. In a normal volume, like the room you're sitting in, if you want to double the information it can hold, you double the volume.
Makes sense.
But black holes don't scale by volume. They scale by surface area.
The event horizon.
Yes, the event horizon. The holographic principle suggests that all the information, all the entropy of a black hole is perfectly encoded on its two-dimensional boundary like a hologram.
Right on the surface.
Exactly. If you add one more bit of quantum information to a black hole, the volume inside doesn't just get denser. The actual surface area of the event horizon expands by precisely one Planck area to accommodate that new data.
That is just staggering.
It is.
It means a black hole is the only object in existence that operates at a perfect one-to-one ratio of maximum capacity.
It is nature's ultimate hard drive.
Wow. Where the entropy, the S, is at its absolute physical peak relative to the space it occupies.
And because it maximizes the reality level scalar to the absolute limit allowed by physics, Sewell categorizes it as level omega. It is the most informationally rich and therefore the most real point in our universe.
But the paper actually goes one step further, and this is where the category theory comes in, right?
Yes, the final piece of the puzzle.
Because Sewell doesn't just call black holes level omega objects sitting inside our level alpha universe. In his category theoretic formalizations, they are explicitly defined as gateways.
Gateways,
So
yes.
how does category theory turn a really dense object into a multiversal bridge?
Well, category theory is a branch of mathematics that studies structures and the mappings between them.
Okay.
Instead of looking at individual equations, it looks at the architecture of entire mathematical systems.
It's the ultimate big picture math.
Exactly. Yeah. In category theory, you have objects, and you have morphisms or functors, which are essentially the rules that translate one object into another.
Okay, so applying this to the universes.
Right, if we apply this to Dr. Sewell's taxonomy, our low-density level alpha reality is one mathematical category.
Got it.
The ultra-dense holographic level omega reality is a completely different category with totally different physical laws.
Right, because the math breaks down at the singularity.
Exactly, because the black hole sits at the extreme boundary condition of our universe, where our math fails and holographic mapping takes over. Category theory defines the black hole as the functor.
It is the mapping mechanism itself.
Yes.
It takes the diffuse physical data of our alpha universe, pulls it in, and fundamentally translates it into the pure, maximally dense quantum information of an omega reality.
It isn't destroying the data at all.
It's compressing and converting it into a higher multiversal language.
It acts as the literal threshold between peers.
Okay, let's synthesize this entire journey for a second. We started with Dr. Sewell's premise that reality isn't measured by size, but by the reality level scalar.
The ratio of hidden complexity to volume.
Right. And using the reality level analyzer to measure quantum entanglement and mutual information, we mapped a whole new hierarchy.
From bottom to top.
We started in the vast, almost entirely empty expanse of our observable level alpha universe.
The empty ocean.
Then we zoomed in to find localized structures, the level beta galaxies, which allowed matter to cluster enough to actually form us.
The islands.
Exactly. Then we explore the hypothetical level gamma, where quantum entanglement renders physical distance totally relevant, operating like a cosmic cloud network.
Pure instantaneous correlation.
And finally, we hit the physical limit, level omega, the black holes that maximize the holographic limits of data storage, acting as category theoretic bridges that translate our reality into something infinitely denser.
It is a profound reorganization of our entire cosmic perspective.
It really is.
By shifting the metrics from geography to information, the void of space stops being this lonely expanse and starts being understood merely as the canvas.
And I think that is the most important takeaway for anyone listening to this deep dive. It cures a very specific kind of cosmic inferiority complex.
Oh, definitely.
When we look at those deep field telescope images, it's so easy to feel insignificant, right?
Absolutely.
To feel like the universe is defined by how much empty space there is and how little of it humanity actually occupies. But this framework insists that the empty volume isn't the metric of reality.
The void is just the lowest tier.
The density of information, the complexity of connections, the depth of the structures, that is what actually holds weight in the multiverse.
We may live in a level alpha universe, but the complexity of the human brain, the density of our own internal information networks, is far closer to the concentrated structures of beta or gamma than the empty void surrounding us.
We are just dense pockets of data trying to figure out the rest of the hard drive.
That's a great way to put it.
And that leaves us with a truly lingering, provocative thought to wrap up today's exploration.
Let's hear it.
Think back to that night sky we talked about at the start. Think about the black holes lurking out there in the dark. For decades, we viewed them with a kind of existential dread.
Total destruction.
Right. But if our vast observable universe is just the low-density, sprawling, empty suburbs of reality, and black holes are ultra-dense omega gateways, what if crossing an event horizon isn't a death sentence?
A fascinating question.
What if falling into a black hole isn't the destruction of information, but an evolutionary leap, a transition into a fundamentally higher, infinitely more complex tier of the multiverse?
It changes everything.
It really does.
Everything.
Something to think about next time you look up at the dark.